Hello, everyone. That is the video that I promised in class about the test review. You're going to watch this video, take notes, and then go on MyLab Math, look for the assignments called Test 1 Practice Problem, complete it. The problems are going to be similar to the ones being reviewed on this review practice. So let's jump right into it. We have to solve this equation and check for solution. I'm not gonna check for solution because I know if I take the right step, it'll be the right solution. However, if you are taking a test and want to check your solution, feel free to do it, and it's safer when you do that because you don't know what mistake you made, and by checking, it can help you discover what mistake you made, and that may have changed your answer on the test. And you don't have to show me that work you do to check your answer. So basically, I do not need your work on the process of checking for your answer. So that's why I'm not even going to bother doing it now. Now, solving this equation involves looking for the LCD, and you know the reason is because you have denominator. Now, the LCD is going to be the least common factor, least common denominator. The least common denominator is the least common multiple of all the denominators of this equation. So in this case, we have 9, 1, and 3 are the ones that we see in denominator. So 9 would be the LCD because that's the least in common denominator for these fractions. So let's multiply by 9. We're going to multiply both sides of this equation by 9, which means 9 is going to multiply every term and fraction inside of these parentheses. We multiply the entire fraction by the LCD, in this case, 9. So that's going to be 9 times fraction 3x minus 2 over 9 plus 9 times the x term equals 9 times the fraction 3x plus 2 over 3 and plus 9 times 1. Simplify, 9 divided by 9 is 1. So that's 1 times 3x equals 3x minus 1 times 2. And then plus 9x equals 9 divided by 3 is going to be 3. And the 3 will multiply the numerator portion of this fraction, which will give me 3 times 3 equals 9x. 3 times 3x equals 9x. 3 times 2, that's plus 6. And 9 times 1 is 9. Combining like terms, 3x plus 9x is 12x minus 2 equals, there's like term here is not including x, so 9x stays by itself. And then 6 plus 9 is 15. So now that you have this equation simplified, you want to move the terms to the same side in order to isolate the variable. And I see that I can subtract 9x on both sides. And that's going to be, and if you want, you can even add 2 on both sides also. So you do it at once. And then your expression with x on one side is going to be 3x. Your equation is 3x equals, that's 17. And then to isolate x, we will divide by 3. And your answer is x by itself equals 17 over 3. And your answer for this equation is 17 over 3. You give it in braces, so as a set of solution. So that's the first problem. Problem number 2, there's no denominator but we do have parentheses. What we would do here, we will distribute the numbers on the outside of each parenthesis in order to cancel the parentheses. So that's 6x plus 11 equals 5x. Oh, not 11, that's 30. That's 30. You see, even myself, I'm making mistakes. So that's why you need to pay attention with what you do. I thought that I was adding, that's why I said 11, but we're multiplying. So that's 3 times 5 equals 30. So 5 times x, 5x, 5 times -6 is -30. And then plus the x that was on the outside. The 5 will not multiply this x. Now we can combine like terms. First side has no like term to combine. We keep it as it is. We drag it down and then combine like terms over here. That's 6x minus 30. 6x minus 30. And then now if we want to move every term with x on one side, that will subtract 6x. That's the step we want to take, and that cancels the x on all sides of the problem. So that should trigger your sense of something we talked about in class when solving an equation. So we have 30 equals -30, which is not a true statement. 30 cannot be -30. So in this case, you will remember that your equation will not have any solution. So that's no solution for this equation. With a false statement like this, you can't allow this equation to have any solution. Actually, it does not have any solution. Okay. Next problem, same thing as the previous one. We're going to distribute whenever there is a parenthesis with coefficient on the outside, because we want to simplify and cancel the parentheses. So 3y, distribute the 3 here, that's plus 3y minus 18 equals the 7y, and you distribute the -3 over to everything inside of the parentheses. So that will leave me with -3y plus 10, not that 10, because we multiply by 3. So -3 times -10 is positive 30. And then now we can combine like terms. And when we combine like terms, you're going to have this situation that happens. We're going to have 3y plus 3y, that's 6y minus 18, and equals 7y minus 3y should be 4y plus 30. Now we're going to move all the terms on one side. We're going to do as we did earlier. We will subtract 4y on both sides, subtract 4y on both sides, and I will at the same time add 18 on both sides. And then my answer with x by itself on one side is going to be y by itself on one side will be 2y equals 48. Divide by 2. And your answer, y equals 24. Again, that's a equation with a single solution. So that is going to be, that's going to be 24. That is my solution. All right, so word problem using equation. I said using equation. So basically, on your test, you are required to show me the equation that models your problem. So I'm not taking just answers. Like you read the problem, pick up your calculator, and then you do the magic in your calculator, and then you send me the answer. And I'm looking at your paper. I'm asking myself, where did he get the answer? No, that's not how it works. You're going to set up your equation that models this problem and then solve it to get the answer. Well, if you just, I don't know, drop a solution for me on the paper, you risk to have half credit, and it's because I'm being generous that you get that half credit. You shouldn't have anything because you don't know what you do. You should be reading the problem first. In a survey at a local university, 23% of students say that they get less than the recommended 8 hours of sleep. 20%, 23% of them get this recommended 8 hours of sleep. The rest maybe don't. The rest maybe don't. Now, in a group of 4,100 students, how many would you expect getting 8 or more? That means the rest that did not get this 8 hours of sleep per night. Now, you have to understand when they give me that, they take the 4,100 students, split it into 2 sets. The set of 23% who get less than 8 hours of sleep per night, and then the rest, which would be either they have more or exactly 8 hours. So that's what they asked me to find. You have 2 ways to do that. Well, obviously, I'm going to do it one way, or let me see, maybe I can do it 2 ways, but let's see. First thing, 23% of these people get the sleep. 23% did not get this amount of sleep. And then the rest get either more or exactly this amount of 8 hours of sleep. Now, what I do is that I'm going to call a variable to solve, and that variable is going to be the number of students who did not get this amount of sleep. Well, in fact, we don't even have to call a variable. So 23% of, so basically what they ask me is the amount of the number of students. Let me call it X. I would call it X, definitely. And then that is, well, like I said, I don't write it down, but X is the number of students who get exactly 8 hours of sleep or more. X is the number of students who would get eight hours of sleep per night or more per night. Okay. Now, X is what? X is going to be the 4,100 students that they surveyed minus the 23%, which is the 23% of this amount. 23% of this amount is 23 times this amount. 23% of this amount is 0.23 times this amount. Basically, you know it, right? So the such and such percent of something is this percent in decimal form, which is divided by 100. and then multiply it by this amount. And then that's it. Then you're going to perform your work, and that's going to be that. Where's my calculator? So we multiply by 4,000 by 4,100 by 0.23, and that is 943. So that's 4,100 minus 943, and then 4,100 minus this amount of students who did not get the amount of sleep will give me 3,157 students. 3,157 students who did not get this amount of sleep, who did get this amount of sleep or more. So recap, or you could just subtract, 23% from 100, because the 4,100 is the 100% of student that was surveyed. And then you would say X equals 100% times 100% minus 23 divided by 100. That will be, let's say 1 instead. So that's 1 minus 0.23 times 400, 4,100, and then X will be the answer for you. So that's gonna be 1 minus 0.23 equals, that is 0.77 times 4,100, and then multiply 0.77 now by 4,100, and that gives you the exact same amount. So you have two ways you can do it. Is you can either do 4,100 minus 0.23 times 4,100, or you subtract 0.23 from 1 and multiply the answer by 4,100. Okay, so call the variable X based on the question they ask you. The variable is always, your variable is always going to be the question they ask you. They say, how many would you expect? How many students would you expect to get 8 hours or more hours of sleep per night? So that's why my variable is X, number of students who would get 8 hours of sleep or more per night. X equals, since they split it into two groups, 23% got less than the amount, the recommended 8 hours of sleep per night, and then the other group, the rest, get 8 hours of sleep or more. And then that gives you the purpose of your problem. So you call the variable and the total 400 and subtract the amount that got the, sometimes they can ask you the opposite. So they can ask you, how many of them got the actual amount of sleep? They can ask you, how many of them got more than the amount of sleep? They can ask you, how many of them did not get the amount of sleep, while they give you the same percent. So you need to find out what they ask you. Sometimes the question may be for you to find this number, which is the amount of students, the number of students who did not get this amount of slip. And while they give you the percentage, now you're not gonna have to subtract. You need to pay attention to the answer to the question before you answer it. Let's see another problem here. I spent too much time of my video talking about this problem. Let's move on. Next problem, a new television set was recently purchased for the common room of a residence hall. Recently purchased for the common room of a residence hall for $514.50, including tax. If the tax rate was 5%, find the price of the television set before tax. That's my variable. Find. I'm just going to remove the find, and then the rest is the name of the variable. So my variable is the price of the television set before tax. The price of the television set before tax. The price of the television set before price. You see, I purposely copy and paste this information for you to remember. That's what the question they asked me, that's exactly what my variable is gonna be. Now, X is the price of the television set before tax. Now, next, they talk about tax because they said this $514.50 is the total price that includes both price of the TV set before tax and the actual tax of this paid for this TV. Now let's see. When you add the price of the TV before tax and the price of the tax of this you pay for this TV will give you the actual amount you spend to get that TV. So since taxes are 5% of the price of this TV, which is X, so tax would be 0.05 times the TV price. And then adding the price of the TV, X, and the tax will give you the $14.50. So I'm gonna have X plus 0.05X equals 514.50. So I need you to give me an equation. It's always going to have a stop by an equation, and then the next step is to solve this equation. So combine like terms, that's 1.05X equals 514.50. So divide by 1.05. 1.05, you divide both sides by 1.05. And then now you have X, which is the TV price before tax that they wanted me to find, equals, so 514.50 divided by 1.05, 1.05 equals $490. $490. So that is the price of the TV, before tax. And now my question, I may ask it on the test too. After a problem like this, I may ask you, so what was the amount of tax this person paid for this TV? So the price of the TV before tax was $490. So what was the price? What was the tax? So the tax will be for $514.50. Subtract 490 on it. So that would be 514 and 50 cents, 0.5, I mean 0.5, I'm typing it, minus 490. So he paid $24.5 in tax. All right, next problem is to solve this for a variable. Let's go. So we want to isolate G and keep everything on the other side. We're gonna go quickly with subtracting 2m on both sides. You need to use the same format of the variable. If you have capital, keep capital. If you have lowercase variable, use lowercase variable. If you give me lowercase variable while the capital variable is what I gave you, you have a wrong answer. Just like my MATLAB would mark you wrong, I will not give you credit for changing your variable. Keep that in mind. So, and you subtract it on both sides. That simplifies this, and then P minus 2m equals 2g divide by 2 to isolate the g, and then g equals P minus 2m over 2. But if you want to continue to simplify, that can be your final answer here. I don't force you to take any further step. But if you want to simplify, you would have something like this: G equals P over 2 minus 2m over 2, simplify 2, and then G equals P over 2 minus m. If you give me that, I can take it as well, and it makes no difference. The only difference, if you did not stop here and you continue to here, and then you make a mistake on your way to this answer, then you're not gonna have full credit. But if you stop where I put this star, you get your full credit on that. Keep that in mind. Number 7 here. We're gonna solve this, but we have to pay attention to what we're solving for. So I'm solving for S, and the S is all the way inside of the parentheses. In this case, we need to distribute. But if the variable you want to solve for is not inside of the parentheses, don't bother distributing, because it's going to waste your time while you could have done it quicker. So let's distribute L over. So that's T equals 6L plus RSL. And I'm solving for S, so I want to subtract 6L on both sides. I'm solving for S, so I want to subtract 6L on both sides. So that cancels 6L. So I have T minus 6L on this side, and then the other side is RSL. And I'm solving for S. I want to divide by RL on both sides. And then that takes me to the answer that is T minus 6L over RL, or if you want to simplify, you can do as we did earlier, which I'm not going to even do now. But if you want to do it, of course, feel free to simplify, but keep in mind, I'm not responsible of no mistake you make on your way to get the most simplified answer. Inequality. How do we solve inequality? Well, basically, they're gonna tell you how to present your solution, but I always want the graph of the solution. So basically, on the test, on the homework, they're gonna say, solve and write your solution using interval notation. Well, you're gonna need to type the interval notation for you to get the answer on MyMathLab. But on the test, if I say give the interval notation, you're going to need to show me the graph first before you give the interval notation. So think about what you would do here before you find your solution to start solving this inequality. Feel free to pause the video to try it. But obviously, you have parentheses. First thing is to distribute the coefficient on the outside, and then find the expression with no parentheses. So that's why that's gonna be 7x minus 35. 7x minus 35 less than 8x minus 4. Now let's regroup the like terms. I always like to subtract. I always like to move the smaller term because I want to preserve the positive sign if possible. So if I subtract 8x, it'll be moved over with 8x, negative 8x plus 7x. It'll be a negative number that will require me to flip the inequality. I will need to flip it anyways, but I prefer moving the smaller term with the variable instead of the bigger term. That's how I would feel. But if you want to do it differently, you feel free to do so. So let's subtract 7x on both sides. Negative 35 less than negative 35 less than x minus 4. Then I add 4 on both sides. And then I would have negative 31 less than x, or you can keep the x on the open side of the variable of the inequality and then put negative 31. It's still the same thing. I just prefer the x on the left instead of on the right, but you got to be careful when you're changing the position. When you change x position, you also flip your inequality. Flip inequality, because if you change x position, it goes from the open side of your inequality, goes to from the open side to the sharp side of the inequality. It changes the whole thing. So you want to keep x on the open side. So that means if you're flipping the numbers, you want to flip the inequality as well. So let me show you the look of the graph of this inequality. So I like to always put 0 on my number line, and this 0, I put it just so I show which side of 0 this number will be located. So once I have 0, this number is the only thing I'm gonna need on the number line. So nobody can tell me that's not the measure of it. They don't know what measure I was working with. So that's why I can put my number anywhere as long as it is on the right side of 0. It's negative, it's going to be on the left side of 0. And then that's going to be infinity positive. So just infinity. So now my inequality suggests that x be greater than negative 33. That means x, everything that x can be should be on the right side of negative 31. So basically, you can use either bracket or closed circle or parenthesis open circle. You can use those. Well, I am okay with both of them. There's no pressure on which one you would use. But in this case, I'm gonna use a bracket and parenthesis. In this case, that's going to be parenthesis for on negative 31, but it opens to the right because with x on the left side of the inequality, greater than means that we are looking to positive infinity. You're walking toward positive infinity as you seeing your solutions. So, and that means I open my parentheses facing the solution. And now everything on the right is going to be solution of this problem. And that shows me what my inequality, that shows me what my solution in interval notation will be. So it's gonna start, that's the graph. And the interval notation is going to be start where? -31. How? With a parenthesis. So parenthesis, -31, comma, infinity. Always a parenthesis to close infinity or open with infinity. Always parenthesis, because it's not a number. We don't even know what it is, but it's infinity. It's not gonna stop. So that's why we call it, we always put a parenthesis on it. All right, so now we have the answer in graph and interval notation. Like if they say interval notation, give them interval notation, but on my test, you are required to give me the graph. And however, I ask you to give me if it's set notation or interval notation. Number 9, they say that we need to solve. Well, to solve this, whenever you have fraction, it's required for you to find the LCD. All the denominators are 7, 5, 35. 35 includes a factor 5. It has a factor 35. So my LCD is automatically the 35. And then I would multiply by 35 to cancel the denominators. So 35 divided by 7. Okay, let me write it out. 35 times 2 over 7 plus 35 times 2 over 5 greater than or equal 35 times x over 35. But you need to remember that's a fraction, that two fractions that we multiply, straight multiply, or I can simplify. Actually, I prefer simplifying because it helps me more than if I multiply and divide. It may be big enough. I mean, if you want to do it, do it. Don't get lost with my trick, but it's easier. So you said 35. You said 35 divided by 7, it's 5. It's a 5 that you multiply by 2. 35 divided by 5, it's a 7 that you multiply by these 2, and then 35 and 35, you cancel them all, which gives you exactly a number without fraction. So we get everything with no fraction now, which makes life so easy. Then now we're going to solve this. We're going to solve this problem very easily because there will be no fraction to bother us. And then now 5 times 2 give you 10. 7 times 2 plus 14, and then that's greater than x. Your solution is 24 greater than x. I always want x to be on the left. So x would be less than or equal to 24. And then now you're gonna need to give me both graph and interval notation. The graph here, I just copy the previous graph and now I'm going to put close on it. So the graph here starts at 24. That means I don't need the left side now. I'm gonna need the right side because 24 is positive. It's gonna be on the right side of 0, 24. And then it's a greater than or equal. Greater than or equal means that I'm going to have a bracket on 24 And now, since it's less than with the x, with the variable on the left side of the equation, less than and variable on the left side means that we are heading toward infinity, negative infinity, to look for the answers, the solutions of this problem. So basically, it's going to open to the right, open to the left, open to the left on 24, and then the shaded part will be everything, oh my God, on the left side of 24. Everything on the left side of 24 is the solution for this problem. And now looking at this graph, you can give your solution set from left to right, please. So from left, negative infinity, and it goes all the way to 24. What do you see on 24? Was it a bracket or parenthesis? It's a bracket. Same case, same situation for this problem number 10. We're going to have to find the LCD. In this case, LCD is 8. Then multiply by 8 everywhere. So that's 8 times the fraction negative x plus 2 over 2 minus 8 times the fraction 5 minus 7x over 8 less than 8 times negative 3. Then 8 divided by 2. 8 divided by 2 is 4. That multiplies everything here. And then 8 divided by 8, it's 1. So that's negative 1. That multiplies everything here. So that's 4 times negative x plus 2. 4 times negative x plus 2 minus 1 times 5 minus 7x less than negative 24. Distribute negative 4x plus 8 minus 5x plus 7x less than negative 24. And then we're going to combine like terms. That's negative 9x negative 2x, because negative 9x minus 7 plus 7x, that's negative 2x. That's negative 2x. And then if you want, that's if we subtract 8 on both sides, less than 32, negative 32. Less than negative 32. And then now what else do we do? So let's recap very quickly. We subtracted 8. That's 5x, negative 5x minus. So that's 8. Oh, that's negative 5. That's not negative 5x. That's negative 5. And then let's take a step back. Oops. Okay, so distribute, that is negative 4x plus 8 minus 5 plus 7x less than negative 24. Combine like terms. That's negative 4x plus 7x. That is 3x minus 3. Plus 3 less than negative 24. Then we subtract 3 on both sides. We got 3x less than negative 27. We divide by 3. And then we receive the answer now that is x less than negative 9. Let me try to re-verify again. That's for x, negative 4x plus 2 plus 8, negative 5 plus 7x less than negative 24. Combine like terms plus 3, negative 4x. Okay, perfect. Now that we have the answer for this, we can graph it, or we can give the interval notation. I mean, both of them actually. So graph, it starts on the negative side. Well, if I want, I can keep this bracket. Oops, I want that. I'm gonna just move it over. Okay, so that's going to be my negative 9 on this side, and then x is less than negative 9, right? So we're gonna put a parenthesis looking to the left side because it's less than. And then my solution will start from 9 and goes all the way to negative infinity. So that's gonna be my shaded section of the number line. And that's it. That's it for the solution. So that's gonna be from negative infinity to negative 9. Both of them parentheses. From negative infinity to positive 9, to negative 9. And then let's see this one here. Okay, so in this problem here, you're going to need to find the solution, but the difference in this one is that you need to realize that we have two inequality, and that's why we call it a compound inequality. Compound inequality is when you have to solve two inequalities at the same time. So you're gonna have to isolate the variable inside of the inequalities. So let's start by adding 7 on both sides. On all sides, I say, and that cancel 7 here, 0 less than or equal to 9x less than or equal to 9, divide by 9 everywhere. And then x is greater than 0, but also less than 1. X is greater than 0, also less than 1. So your interval, your graph of this will be let's see what the graph would look like. 0, everything has a bracket, obviously. Everything has a bracket because you have inequalities. You have less than and greater than, both less than. So at 0, we put a bracket because x is greater than 0 or equal, it's included. And then 1, you're gonna put a bracket as well because x can be also equal to 1. So, and then the shaded section of my number line for the solution is everything in between. So that's the shaded section. And then the interval notation will include only brackets from 0 to 1, and that's it for the interval notation. And then keep in mind, if you need to put bracket, you give me parentheses, you have a wrong answer. Even though the numbers are good, if your bracket or not same, like if it needs to be bracket, you put parentheses, you'll miss the question. If you need to give me parentheses, you give me bracket, you miss the question. Even though your work is good, and I can give you like some type of work for credit for your work, but you're gonna miss half point or more if you miss any part of this. Make sure you understand it, because I'm looking for you to understand things and to know the steps to work through things. It's not just like, whatever I remember, I give it, and if I don't remember, I give up on it. No, try to keep it the entire process. Okay, so now let's see this one here. What is it? It's a compound inequality. Then we're gonna need to also find the least common denominator. In this case, it's easy to find because it's one denominator that is 4, else it is 4. Multiply everything by 4. Negative 32 less than or equal to negative 3x plus 1 less than or equal to 44. And then now we need to subtract 1 on both sides, and gives me the new equation now that is negative 33 less than or equal negative 3x less than or equal, that's 43. That is 43. Now what next? Next is that we are trying to isolate x, but the one thing that happens here is that as you can see, there's a negative number inside of the bracket of the inequalities. Now that you need to pay attention to it. It's not as usual, you just divide by negative 3 and then it keeps the same side. Now, after you divide, the answer that was on the right here would be moved to the left, and the answer here will be moved to the right. So you swap the numbers side. Well, the x will remain in the middle of the problem, but the end numbers will be flipped. Again, I'm saying when you divide a compound inequality with less than sign, less than or equal sign, by a negative number, you swap the answers from left to right and from right to left. So that said, and everybody understands, we divide by negative 3. We divide by negative 3. And then that's going to be negative 43 over 2 less than or equal. You see how this one, let me put them in color for you, because I want to make sure you guys understand what happens here. So this one moved over here. I moved it over here after I divide the compound inequality that includes a less than or equal or less than, just that. And then that one here will give me obviously positive 11. Positive 11 would be on this side of the problem. Move it over, you swap them side. And then now that's what we have. Then we can give the answer in first we're gonna graph it. And next we're going to give the interval notation. So that said, I'm going to call this negative 43 over 2. It's over 3 over 2 over 3. That should be over 3. That should be over 3. And that also is over 3. Okay. And then 11 will be on the right, positive. And then both of them will be assigned a bracket because x is greater than negative 43. X is greater than negative 43 over 3. The bracket looks to the right because x is greater. X is greater, bracket looks to the right. X is less, bracket looks on the left. And then that's why you always want to read your inequalities with the x instead of the number. X, how is x? And then you know which way you go. If x greater, open your bracket or parenthesis to the right. If x is less than, open your bracket or parenthesis to the left. And then now the interval notation for this will be the bracket negative 43 over 3, comma, 11. And as you can see, I don't even bother dividing because it's negative, it's on the left, it's positive, it's on the right. Whatever it is, the position really doesn't matter. What matters for me is where you put it, and that's why I want you to put 0 always so you can locate your numbers. But dividing it to see the decimal, I don't care. You don't even have to. Now, let's see this one here. Easy. That one is easiest. Is the easiest ever. +1 on all sides. +1. That's 1 less than or equal 3x less than or equal 21. Divide by 3. And then we got 1/3 less than or equal x and less than or equal to 7. And then give me the graph for that. That should be the easiest thing you can possibly imagine. So that's this. Just copy this. Makes it easier for me. Obviously, the interval notation will be 1/3 7 with bracket, of course. And then the graph is going to be, everything will be on the right because all the numbers are positive. 1/3 will be somehow close to 1. Let me put it here, 1/3. And then 7, right? And then the bracket here, I can just copy it over on 1/3. And then I also need a bracket on 7 because it's included. And then the shaded section will be the section in between the two numbers. So that's a graph for my for this problem. And this compound inequality, what do you do here? I do want to solve it too, because you never know. You're gonna say, oh, you didn't do this one. Well, so let's distribute that. That's negative 20 less than 5x minus 20 less than or equal to 4. Then we add 20 on both sides, right? And then that's 0 here, less than 5x less than or equal to negative 16, right? And then that said, you're going to negative 16. Let me check this, making sure negative 20 cancel for 0. And then should we be adding 20 here? So that's going to be 24. So that's 24 because we're adding, not subtracting 20. And then we divide by 5. And then that is 0. We divide by 5. That's 0 less than 0 less than x and less than or equal to 25 or 4. 24 over 5. Your graph that's 0, and it's one of the numbers that I want, and then 24 would be on the right, obviously, 24 over 5, and a bracket on 24 over 5, and then a parenthesis on 0. And then we do need to shade the section that represents the solution. In this case, it's going to be the inside part. And then the interval notation for this will be, the interval notation will be from 0, that's a graph, and that's your interval notation. 24 over 5 is the answer for that. So now let's go ahead and see what we have in number 15. Number 15, it's a graph. First thing you need to realize that this says determine whether the equation is linear or not linear. It's linear because you have all the variables have the power 1. So power 1 for all variables, then it's linear. It's linear, right? We talked about that. So your answer is yes, it's linear. It's linear. And then you're going to, it says, then graph the equation by finding and plotting ordered pairs solution, ordered paired solution. So, well, if it says it, I would do it, but we could do it linear. I think the easiest way to solve this would be to solve for the slope-intercept form. So if we add 3x on both sides, that gives you y equals 3x plus 5. So your slope is 3. If you want, that's going to be 3 over 1. And then the y-intercept is going to be 0, 5. So we're going to start with the y-intercept 5. The y-intercept at 5. From that, we're going to go up 3. and over 1, or 3 over 1, or 3, 1, 2, 3, and over 1. If you want, you can have another one. You can go down 3 if you want to, but this time you're gonna go left. Down 3, 1, 2, 3, and then left 1. So now that I have this, I can connect the dots to get my line. Can connect the dots and get the line. That's a beautiful line that I'm gonna get, of course. Okay, so that's the line of the equation y minus 3x plus 5, y equals minus 3x equals 5. All right, so let's see this one. That's also going to be a yes because it's linear. All exponents are 1. All exponents are 1 for the variables. So that means it's linear. And then we want to find the slope-intercept form so we can graph it. So let me subtract 5x on both sides. So that's negative y equals negative 5x plus 2, divide by negative 1, everything. So you can isolate y. Y equals 5x minus 2. Your slope is 5, and your y-intercept is 0, negative 2. So now that you have this, we're going to try to find the y-intercept first. That is at negative 2 on the y-axis, negative 2 on the y-axis, and then try to read the slope. The slope is 5, but 5 over 1 is what you're gonna keep in mind when you're looking for graphing the line. So slope, you see, from this point, I'm going to go up 5, 1, 2, 3, 4, 5, up 5, and then over 1, right? And then if you want, you can even repeat that so you can have a better pattern of your graph. From this, I'm gonna go up 1, 2, 3, 4, 5, and over 1. I have another ordered pair here. And then I can connect, just like we did earlier. So that is the equation of my line right here. That's the equation of my line. 5x minus y equals 2. 5x minus 9 equals 2. How about this one? So because you have an exponent, any transformation that happens to one variable makes this equation not a linear equation. Whether it's an absolute value, it's a radical, it's an exponent, or any other thing that you may learn in your future math classes, then this will make this expression not a linear expression. So this one is not linear. This one is not linear. And then now, so if it's not linear, they say identify the graph of this, right? So it's not linear. These ones cannot be solution. One of these are going to be the solution here. So exponent 2 will give you the parabola. Both of these are parabola. But if there is a negative sign in front of x squared, the graph of a parabola faces down. And if there is no negative x in front of the x squared term, no negative sign in front on the outside of the x squared term, the parabola looks up. So that makes this one your answer. So the parabola looks up when the x squared is positive, and when x squared is negative, the parabola looks down. The VLT, the vertical line test, tells you which graph is a function. So by looking at this one with your eyes only, you can tell clearly that this is a function. Now, find the domain of a function when it's given on a graph, domain, range, and determine whether it's a function or not. That's what this problem is about. So now I have this graph, right? We need to find out how far this graph goes from left to right for the domain, and how far it goes from the bottom, from bottom up, and that's going to be the range. But there are three things that I need you to remember from here. We need to remember, you need to look at how the graph ends. You need to make sure you look at how the graph ends. The graph can end with a empty circle, open circle, can end with a closed circle, a circle that is filled, or can end with a arrow sign like this. Now, ending with the open circle, open with a closed circle means that you're going to, on this value, you're going to use parentheses as you're giving the domain and the range. So now if I have an open circle and then I point out the x value for this end of the graph with an open circle, it's going to have a parenthesis. Same thing, you can close it too, or you can have a bracket to close it, depends on how the other side is. Same thing over here, if you have a closed circle that ends the graph, you want to use a bracket, and same thing on the other side. If it's a bracket, you put, if it's a closed circle, you put bracket. If it's an open, you keep a parenthesis. Now with an arrow sign, you're always going to end it with a parenthesis, but that means this thing goes all the way to infinity. Now you need to imagine your graph, how it tends to go. Like if you have a graph like this, right? It goes down, but also it's going to the right as well. So that's going to be used for both domain and range. We're going to do some examples. And the last thing that I want to say is that if there's no sign on a graph, like that you can see an open or a closed circle or any arrow, consider it as a closed circle. Consider all unseen side signs as closed circle. So now that you know this, in this one, some of you may want to ask, where are the closed and open, or where are the arrow signs? Well, if you don't see anything that is one of these three, it's a closed circle. Now, in this case, it's going to be a closed circle. Then another thing that you need to watch, look at how they give me different type of answer. Single value answers. Single value answers. It's when you have the function, for example, you have it in diagram, mapping diagram, or you have it in set notation, right? When you're giving the domain, you're going to list the value one. Oops. You're going to list the value 1, 2, 3. These are single values. But when you're looking at this thing, it's a continuous function. You can count the points. You can't. So the fact that you can count the points, your answer is going to be in interval notation. Interval notation. Obviously, that's when you're going to use parentheses, you're going to use bracket, you're going to use the values and the endpoints of the graph. So for this one, it's obvious that our answer is automatically going to be the interval notation answer. Now let's give the interval notation. For the domain, how far left this graph go? Your answer should be -1 on the x-axis, right? The value of x here is -1. So I'm going to start my bracket with it's a closed circle because I told you when it's not seen, it's a closed circle. So -1, and then I'm going to look at my graph again to see how far it goes to the right. That's a 5. So it stops on the right at 5, and then I put a bracket because there was a closed circle. Well, I said closed because if it's not open, it's closed. Let's see for the range here. The range, though, will be, from the bottom up. You don't read it up, down. You should read it bottom up. So starts here at -5, right? So that's a bracket -5. Goes all the way up to 1. Close bracket. And then now they're trying to check me to see if I remember this idea of vertical line test. You look at this graph and you tell me quickly that this did not pass the vertical line test. But they don't want you to just say that. They want you to state something for them to see if you understand when you say vertical line test. Do you understand it? Well, let's see. Obviously, this graph did not pass the vertical line test. So that means it's not, the graph is not the graph of a function. It's not the graph of a function. So we use is not the graph of the function. And they're gonna want me to say why. Not a vertical, so is not the graph of a function because the vertical line, because a vertical line, and then the options are can and can't, cannot. Which one you pick? Well, can be drawn. Can be drawn so that it intersects the graph multiple times. Can be drawn so that it intersects the graph multiple times. Can be drawn and then intersect multiple times, more than once. All right, try this one based on what you learned. First, it's a continuous function. So the domain is going to be, in interval notation. Whenever you have a continuous function, domain is interval notation. A is your choice. And then starts from left, arrow signs, sign, negative infinity, to right, arrow sign, positive infinity. And then the range from the bottom, though, starts at 1. So it's continuous. So still going to be the interval notation option. And then the bracket here is going to be a bracket because if I don't see anything when it starts, that means it's a closed circle, 1. And then it goes all the way up with an arrow sign. That means it's infinity, but obviously bracket. Check this one. Does it pass the vertical line test? I'm curious. Well, your answer is yes. So that means this graph is the graph of a function. Is the graph of a function. And then when you know it's a graph of a function, that means you see clearly there will be no way, no line, no vertical line can be drawn to intersect this thing twice. No vertical line can be drawn to intersect this line more than once. So is the graph of a function because a vertical line cannot, because that's what they give me. A vertical line cannot. Now, if they said no vertical line, you would say can be drawn, but they say a vertical line cannot be drawn. If they say no vertical line, you would take can, but if they say a vertical line, you need to use cannot be drawn so that it would intersect this thing more than once. There's no way that will happen. So cannot be drawn so that it intersect more than once. All right, let's calculate f of 0, f of 14, f of -4 when f of x equals this. You need to show work. I don't know how much work it requires, but don't tell me, oh, that's obvious, and then I can just do it. Well, show me what you did. So that's why that means f of 0 means plug in 0 for x. So that's 1/2 times 0 equals 0. So now you tell me that what they want me to find, f of 0 equals 0. That's your answer. You need to know how to give clean work. That shows me how clean the thing is in your brain. That equals itself 1/2 of 14. 1/2 of 14 is 1/2 times 14, which is half of 14. That is 7. So f of 14 equals 7. Again, that is the other answer for f of 14. And f of negative 14 is negative 1/2 times negative 14. Oops, times 14. That's 1/2 times negative 14, which is negative 7. So f of negative 14 is negative 7. Okay. That was it for this one. Now, what you need to remember is that sometimes you're gonna see your equation that has, you're gonna see your equation that misses some variables, because your equation of a line is always in the form of y equals mx plus b, or there is an x and there's a y. Now, what happens is if your equation misses one variable, you need to remember that. So if your equation, when your equation shows, when equation only shows, when equation of a line, I need to say that too. When equation of a line only shows the x variable, you have two consequences happen. First, the line is vertical. And then second, the slope of the line is undefined. The slope of the line is undefined. So this line is vertical, so it passes through -6, passes through -6, it goes from here and goes down. It's a vertical line passing through -6. So that's my line, x equals -6. And we know it's vertical because it does not have the y. And what happens if the equation of the line does not show the x, it shows only the y variable? You can anticipate what the answer would be, right? If the equation of the line shows only the y variable, the line is horizontal. The line is horizontal. horizontal. The line is horizontal and the slope is 0. The slope is equal to 0. Okay, so then we have a line y plus 2 equals 0. So that is, when you subtract 2 on both sides, that's y equals -2. And the line, the graph of the line will be, that. So that's the equation of y plus 2 equals 0. So what's next is so we're moving on to the next problem. We finished the synthetic division. Now we're trying to see this one here. This one is the division of a monomial by, a binomial by a monomial. So whenever you're dividing by a monomial, you don't have to do synthetic division or long division that you will see later. Now let's do this one. You separate it, give each numerator their own denominator. So that's 16, a to the 7th, b to the 2nd over 4a to the 6b plus the second 28 a to the 6th b over 4 a6b. Now we can simplify this. 16 divided by 4 is 4. 7 minus 6, that's 1, just a. And then 2 minus 1 is 1, so that's just b. Plus 28 divided by 4, 7. Same exponent for the same variable, so that's 1. Same exponent for the same variable, that's 1. So that's just 7. Let's try this one. That one is a trinomial divided by a monomial. Still the same thing happens. You just separate this expression with separate denominators. So that's 24 x to the 7th, y to the 4th over 4xy to the 3rd plus 20 xy squared to the over 4x to the xy to the 3rd, and last plus 8 xy to the 3rd over 4xy to the 3rd. So we'll simplify. 24 divided by 4 is 6. X to the 7, x to the first power, so that's x to the 6. Y to the 4th, y to the 3rd, that's just y. You subtract 3 from 4. Plus 20 divided by 4, that's 5. X has the same exponent, cancels each other to 1. And then y2 on top, y3 in denominator. We better move the 2 down to subtract with 3, and then you got a y in denominator. And then last, plus 8 divided by 4, that's 2. Same exponent, so that's just 2 for that. And last, we have this synthetic long division. We want to do it with long division, but of course, if you want to do it with synthetic, I can try to show you how to do it in synthetic division as well. But I want to do long division for this one as the main way to solve it, because some of the problems, they're going to ask you to do it using long division. So long division, the top is your dividend. So that's 3x to the 4th minus 21x to the 3rd plus 19x to the 2nd minus 9x plus 18 and the divisor is x minus 6. Now, first thing you do as you are looking for terms to put in the quotient section, you take the first term, the highest degree term, the leading term of the dividend, 3x to the 4th, divided by the leading term of the divisor, which is x. So it gives me 3x to the 3rd, and that is the first term that's going to appear on the quotient section, 3x to the 3rd. Now, if you remember how you would perform your your long division with a simple number, that's exactly the same way, right? The same process. You would, if you would divide, I don't know, 55 by 2, you would say, oh, how many times 2 goes into 5? You would say 2 times. So you put the 2 here, multiply 2 by 2, and then get that number 4, subtract it from 5. That's 1. When you subtract, minus, and then drop the 5. Then how many times you restart the process again? How many times 2 goes into 15? You would say 7 times, right? And then you multiply the 7 by 2, that will be 14. And then 14 subtracted from 15, that will be 1. This called your remainder. This is your divisor. And that's your quotient. And that it was your dividend. Now that you have this information, we can use the same techniques to divide when it comes to polynomials. So remember, first thing I did, I divided the leading term of dividend by leading term of divisor. It gives me this. That's the first thing goes in quotient. And then now I'm going to try to find what I'm subtracting here. So let's multiply this term added in the quotient section by each term in the divisor section. 3x to the 3rd times x. That's 3x to the 4th that we subtract from the 3x to the 4th here. 3x to the 3rd times 6 is negative 6, I'm sorry. That's negative 18x to the 3rd. We subtract negative 18x to the 3rd. That's going to be positive 18x to the 3rd. Subtract this, that cancels, and we have negative 3x to the 3rd. Now, I'm going to restart this to find the next term in the quotient. Same thing happens again. that was the first step, but the second step, I'm going to take the negative 3x to the third that I divide by the highest term in divisor. So that's x. That's negative 3x squared that goes right next to the first term that I added in the quotient section here. Repeat the process, it multiplies everything in divisor. So that's negative 3x times, oh, I forgot to say that we need to drop the next term. What? We did it, right? So that's 19x to the second. Now, negative 3x to the second multiplies x to give me negative 3x to the third, but we subtract it here, so that's positive 3x to the third, because you always want to subtract, just like we did for a regular number. And then negative 3x to the third times 6, negative 6, is positive 18x to the third, that I subtract 18x to the second, sorry, over here, cancel this, and I got 1x squared left. Drop the next one, negative 9x. And then again, you repeat the process. That's x squared that divides x by x, that is x. So x is the next term in the quotient section. And then we multiply it by everything in the divisor. So that's negative x squared, because x times x is positive x squared, and you subtract it. X times negative 6x is negative 6. X times negative 6 is negative 6x. And then you subtract it, becomes positive 6x. And then cancel the x squared, and that's negative 3x. Drop the last term here, that's the 18. And then to get the next number goes in the quotient section, we take the negative 3x that you will divide by x, that's negative 3. And then negative 3 times x, negative 3x, that's plus 3x. We subtract it. Negative 3 times negative 6, that's positive 18. So subtract 18 here. That cancels the 3x, and that cancels the 18. Remainder is 0. So the only result we have that now is that, and that is our quotient here. That's the quotient. So your quotient is, and that because the remainder has 0, then we don't have the part that remainder divided by divisor. We don't have this part, since the remainder is 0, and this fraction reduced to 0. So that is the answer here for this long division that I did. And then we can do the synthetic division here, right? Let's try it by synthetic division. With the synthetic division, we process the same way. Synthetic. So we create the boxes, the box. All right, so that's the box for our synthetic division. We're not missing any values. You can see that we go from 4, 3, 2, 1, and 0. So we go smoothly down, no jump. So we're not missing any term. So we're gonna put the coefficients 3, negative 21, positive 19, negative 9, and positive 18. We're gonna solve x minus 6 equals 0 to find the number that goes on the outside. X equals 6. So 6 goes on the outside. So 6 goes on the outside. Drop the 3. 3 times 6 is 18. 18 minus 21 is 3, negative. Negative 3 times 6, negative 18. 19 minus 18 is 1. 1 times 6, 6. 6 minus 9, negative 3. Negative 3 times 6, negative 18. 18 minus 18, 0 remainder. So we subtract the exponent in denominator from the exponent on top, the largest or the degree of the polynomial in the numerator minus degree in denominator. So that's 4 minus 1, it's 3. So x to the third minus 3x, you go down smoothly just like it was here. Minus 3x squared, plus 1x, and minus 3. So that is your quotient, which is the same as what we got from the long division. So obviously you would say, some of you and most of you would say, oh, that's easier. I'm gonna do that only. No, if I ask you to give me the synthetic division, you give me synthetic division. If I say long division, long division. Well, that's it. I hope that you're going to enjoy this review video. And then I will see you next class.